Using client-side rendering or server-side rendering is a never-ending battle among developers. But is one truly better than the other? When using front-end frameworks like React or Angular, we need to render our components by generating the HTML markup correspondent to each of those components. There are two approaches to accomplish this: client-side rendering, which happens on the client's web browser, and server-side rendering, where the HTML is generated on the server and then sent to the client. Each approach has its own advantages and disadvantages, and in this video, I'm going to put them to the test and show you how you can use both and how you can decide which one to use depending on your needs. To help us see both in action, we are going to use Next.js. In case you don't know, Next.js is a full-stack framework built on top of React and has an easy-to-use mechanism to render components between CSR and SSR. So let's start by installing it by simply typing npx create next app. Let's use the latest version and give it a project name, or simply put it dot to create the project in the current directory. And now simply click enter on all of the options. Now to run it, simply type yarn dev or npm run dev if you prefer npm. And now you have your Next.js server up and running. To make this example easier, let's go ahead and delete all of the main page's HTML and add a simple div in the header saying CSR versus SSR. Now create a new component file named data.tsx and import React. Create the component variable with a simple empty div and export it. Back in our main page, import our new component, and let's go to the browser just to check if everything is okay. Okay, perfect. Everything seems to be working fine. Okay, so by default, Next.js renders the components from the server, but let's first try the client-side rendering. To do that, go to our data component file and import the use client directive at the top. With this, we are simply telling Next.js compiler to include this component in our JavaScript bundle. Let's now try to fetch some data as we would in React. So first, create a use state for our data and pass in null. Next, we want to fetch the data on component load. So we can do that by using the useEffect function with the empty brackets. Inside the useEffect, fetch some random data from the JSON placeholder open API, get the response, get the JSON, and finally just set our data state with the JSON. Finally, simply create a paragraph that checks if the data exists, and if it does, print the stringified version of the data. Otherwise, just print a text saying loading. By going to the browser and reloading the page, we can now see that we get our data and it is printed on our screen. But if we go to the Networks tab and click on the first request, we can see that we get the HTML of our application with the loading text. This is because the server sent the initial HTML state to the client. The client then made a request for the data, as we can see here, and then Next.js simply rendered the component with this new data on the browser. Now let's do the same thing, but on the server side. So comment out our current codes and remove the use client directive. Fetch the data, get the JSON, and make the component asynchronous. Back in the browser, refresh the page, and in the Networks tab, we can now see that the server returned the HTML to the client with the data already rendered. In this case, the data fetching was done on the server side instead of the client side, and because of that, the server had all the necessary information to render the HTML and send it to the client. Now that we know how to use both methods, let's see where each method is better than the other. Let's first test the speed of each of the rendering methods by adding a slow 3G throttling on our network. First, we'll try with the server-side rendering, so reload the page and wait for it to load. And as you can see, it took about 2 seconds with the slow internet connection for the page to load, which was all the time needed to simply receive the rendered HTML from our server. Now let's do the same thing, but by rendering the component on the client. Okay, so it took about 40 seconds in total to receive the first HTML, load the other resources, fetch the data, and then render the component. I think we can safely say that SSR wins this round. In terms of search engine optimization, I think this one is a no-brainer. Clearly, server-side rendering is the best option, since it's the only option that gives us the full HTML page on reload, giving all the information that the search engine needs. If we render on the client, we risk not having useful information in the HTML for the engines to work with. And if the application is only doing client-side rendering, then we don't even get SEO, since there is no HTML on page request. If we have a page in our application that can only be accessed by an administrator, then probably client-side rendering isn't the best approach. When a user tries to access a restricted page, the client requests the page content, and upon receiving it, uses JavaScript to check if the user is authenticated. If not, it may redirect the user to a login page or display some kind of error message. The problem with this approach is that the authentication logic and user permissions are exposed in the client-side code. Even if you minify and obfuscate the code, determined attackers can reverse engineer it to discover vulnerabilities or potential exploits. By rendering this page on the server, you ensure that the authentication logic and sensitive user data are kept on the server, hidden from the client-side code. Only if the user is an administrator, then it can receive the HTML. So let's see this in action by creating an admin page. And inside, we can create a function that simulates user authentication and simply return the admin page with the sensitive information if the user exists and it is an admin. Otherwise, it simply returns something else. Now, by going to the Networks tab, we can see that there is no way a user can access the sensitive information without being a valid administrator. If we change the user to an admin, then we will receive the intended admin page from the server. But while server-side rendering seems to be the go-to method, it has a major disadvantage. Every server component does not have access to the browser's API or events like button click events. This major flaw means that we cannot have highly interactive components when doing server-side rendering. If we want more interactive components, we have to render them on the client. So what's the best solution? Well, why not use both? My personal recommendation is to always default a component to be rendered on the server unless it needs a browser event. Let's build an example by creating another component called list and fetching all of the to-dos from our API. We will display the list of items, and each item will contain a simple button. If the item is not completed, then clicking the button will mark the to-do as completed by simply logging a string indicated that it is completed. And as you can see, we get an error saying event handlers cannot be passed to client component props. This is because we are trying to use a browser event on a server-side component. So in order to fix this, what we could do is, well, turn this old component into a client-side rendered component. But that will go against all we've just learned. We would make the loading of the component slower, and possibly making it vulnerable to sensitive information and simply having a worse SEO. But we don't need interaction on the whole component. We simply need it on the button. So let's create a new component just for that button, pass in the HTML of our button and make it render on the client. Now simply change the HTML of the button with our newly created component, and you can see that it now works and all of the page is rendered on the server except for the button, which will be rendered on the client's browser. This way, we have a more granular control in choosing what needs to be rendered where. Now, like every other technology, there's never a holy grail. Everything has its own advantages and disadvantages. Learn as much as possible and use the best technologies and methods for the use cases you have to deal with. And I can assure you, you will always have the best solution at hand. I hope you guys liked it. Hit like and subscribe, and I'll see you guys in the next one. Cheers.